Welcome to Faith, Fiction, and Folklore, or as we like to call it, the Tri-F podcast, where we try not to mess the podcast up. Today, we are going to be talking about the flat Earth. This is going to be quite the involved subject because it seems like there's a lot of details. We're talking about zeniths and equators and orbits and all sorts of crazy stuff. So we're going to try to go into it in detail, and for the first little bit of this, we're not going to be debating anything. We're just going to be trying to distill what the theory is, why people think what they think, because people generally criticize the idea, but nobody ever really talks about the details on why people think there's a flat Earth and everything like that. So we want to explore it and break down what the issue is in detail, and then if we want to debate it later, we will. And Cody is going to walk us through it because he's our flat Earth expert. And all that good stuff. So before we begin, though, let's do our introductions. Turtle Chief, how are you this evening?
I'm good. How are you?
I'm good. Cannot complain. I guess my name is Gary Paul Varner. I should probably say that. I'm a writer for Mind Matters News, and I'm also hosting this podcast or co-hosting this podcast. Mr. Cody, how are you?
I'm good, my brother. Beard's looking fantastic.
Sweet. That's so much oil and creams and help. So
I don't do anything with mine.
I know, and yours is just the proof that genetics rules.
I might get a little trim here and there, but that's about it.
Yeah, looks pretty good.
Some of us have to work very, very hard.
You're telling me.
I don't work at all on mine.
All right, Mr. Cody, are you ready?
I'm sure.
All right.
I'm just going to run through my Telegram page. We're going to kind of doom scroll this thing and pull out little tidbits I've found over time.
Okay, sweet. And I will stop you whenever I have questions, which might be quite a bit.
Okay.
All right.
I'll go ahead and share my screen here.
All right, here we go. Whenever you're ready.
Window. Okay, steal that.
All right.
Can you see that?
Yep.
All right, I'm gonna hit play on this video. I feel like this is a good, a quick rundown on pretty much what I think.
Okay.
Oh.
Well, that's disappointing.
It got taken down.
You got taken down? Oh, they don't want us to know. What are they hiding?
Let's go to the next one.
Truth is out there.
Is
Part of
thrust?
the Matrix.
Well, how about I ask you a question? Is thrust possible in a vacuum? What do you think?
Thrust possible in a vacuum? I would think not, because you'd
Yeah,
need
so
oxygen, right?
Yeah, right. You have to have a what do you call it? Something to push off of. A medium to push off of.
Oh, you're talking about like anti-gravity. Well, I think you just have an initial push of some kind, and then it just kind of keeps going, doesn't it?
I guess that's what they say.
I mean, I don't know. I would think so. I mean, the
I mean, how
force
would
has
you
got to
speed
go
up
somewhere.
the-
I don't think a vacuum would cancel out the force. Do you?
No, the force wouldn't be able to. It wouldn't have anything to push off of.
So what? Okay, well, let's break this down because I'm dumb. So if you've got two bodies floating in space, and they're in a vacuum, I guess, and then one pushes off the other, that motion should make them both bounce off in opposite directions, shouldn't it?
Yeah, but where's the initial force coming from?
With the lifting of the arm and the muscle motion, like the kinetic energy from the movement of the arm.
Yeah. But if you have a spaceship, it leaves the Earth's atmosphere and it wants to slow down or speed up. How is it going to do that with no medium to push off of or push against?
It's a good question. After a certain point, you would think it would just kind of go faster and faster in the same direction, wouldn't it? Or maybe maintain the same speed in the same direction without any need for additional force.
Yeah. But then every space mission we've had would have been a failure because it would have just kept going.
Maybe. Let me think about that. So if you don't have boosters in an opposite direction, I could see you being right. But if you have boosters like directing the craft, wouldn't that fix it?
Right, but what are the boosters what medium are the boosters pushing off of?
I see what you're saying.
or thrusters, I guess.
Okay. That is a very technical physics question. I would think that the motion or the I don't know what, because we use propulsion, so the explosion would be forcing things in a particular direction. Like the motion, I guess you would say, is coming from the craft itself, not necessarily. Like, I understand what you mean about the vacuum. Because it's a vacuum, there's nothing to bounce off of, right? But you would think that motion, that force, still has to go somewhere, and it still has to interact with something. Otherwise, you would have like the complete secession. Like a vacuum would mean like a complete secession of reality. Like there still has to be a cause and effect. So
well, I mean, that's why they call it space. It's space. Think about the word space. It's nothing.
Yeah, well, technically,
it doesn't exist.
It doesn't have air. It doesn't have air, and but it does have radiation and dust and all sorts of stuff. So, by the traditional theory,
right? Okay. Well, after hashing all that out, let's watch this over.
Okay. All right.
Here we go.
Go. Okay, so what did we look at?
As you can see there, if you're listening at home. So that is a vacuum. I mean, obviously it's not a strong vacuum chamber because it's made out of glass. So
right.
I mean, it can't be that much pressure, or lack thereof. But he's got a drone inside a jar. The drone goes up and down, and then he turns the vacuum pump on, and the drone won't come off the floor. So
okay.
Personally, I feel like that nullifies the idea of thrusters and boost and all that in a vacuum, because we can't build a container to achieve a perfect vacuum because it pulls so hard.
Mm-hmm.
Like they've actually tried to make vacuum chambers that will hold a perfect vacuum, and they cannot do it.
Right.
It's not replicatable.
Right.
So I find it very interesting.
So quick question. Was that just kind of them showing that we can't go to space?
No, it was just saying it was nullifying the claim that spaceships work in space. That's what it was attempting to do.
So they can get to space, they just don't work when they're there.
Right. I mean, we're talking about the physics behind it. Is it achievable based on our current physics?
Oh, okay.
Well, it sounds like we're having a conversation about what exactly is a vacuum. Is that just hyperbole, or is it literally a vacuum where there's nothing? Like we say vacuum is space.
There is a perfect vacuum. There's a measurement for it.
Okay, but would space be that perfect vacuum?
Yes.
Okay, why?
That's what they've written down.
Well, no, they call it a vacuum. It's just I don't know how, based on what I understand the term you're using for vacuum, I don't know how they would be able to define that. Like, I don't know if the scientists would define it that way, because you've got radiation, you've got gravity, you've got all these different forces at play. There's no air, and there's none of the gases and stuff that a planet has, but you still have particles and light and dust and different things interacting in it. So I don't know if it would be a traditional vacuum, like say with a light bulb or something like what we just saw. I know they use that hyperbole, but I don't know I don't know. I'm speaking from ignorance, but I don't think that's what they mean.
Well, they measure vacuums. They have different measurements for a vacuum. I don't remember what the term is for it.
Okay.
It's not Kelvin, but it's something,
okay,
something along those lines. But yeah, I mean, in the record books, as far as when you look up measurements for a vacuum, I believe space is the placeholder.
Okay.
For a perfect vacuum.
Okay. I'll take your word for it. I don't know. So
yeah, I'm pretty sure that's how it works. I could be totally wrong.
Okay.
We could watch this one. It's about an azimuthal grid, I believe. Yeah, azimuthal grid of vision. So this is explaining that you have a personal dome of vision. You can't see beyond that unless
Okay.
you bring a magnifying lens into it, or whatever. But
Okay.
so your personal dome of vision is applied to the measurements for the globe.
Okay.
I think that's what this is.
So, to make sure I understand this, what you're saying is, and I'm pointing. Do I have a cursor that'll show up on here? I do. Okay, so if you're standing here, if I understand what you're saying correctly, if you're standing where my mouse is right here on the planet, can everybody see that?
Negative.
No? Okay.
I can't. It's too small for me.
Okay, well, let's say you're standing on the bottom half of that sphere there, that half a sphere there. Then you should only be able to see a portion of the stars and a portion of the orbit. Is that what?
Right.
Is that the claim?
Yeah.
Okay. All right. I just want to make sure I understood that.
Okay. All right. We're going to hit play.
Yep.
So watch this. There it is. Sun's above your head and then it sets. One more time. That's exactly what is happening, okay? Let's change latitudes now. Let's go to the North Pole. If you go to the North Pole, the North Star would be directly above your head at your zenith. So if this is the latitude of 45 degrees, because if the equator is here, this black line, that's 0 degrees. That's 45, which is right in the middle of 0 and 90 degrees. Okay? So the 45-degree parallel, the North Star is visible 45 degrees. The North Star would be here. Okay? So if you're at 90 degree north, the North Star is 90 degrees above your head. 40 degree, then it's 45 degrees above your head. Now if you're at the equator, the North Star would be directly 90 degrees. You wouldn't even be able to see the North Star if you go past the equator. See? Watch, I'm going to show you. But first, you're going to see how it looks. See, now it arches. It's going this way because the sun is at the equator, but you're not at the equator. So the sun doesn't go directly above your head. It does this arc. It does a curve instead of a straight line. So the sun would never do a straight line at the North Pole. It would always go around you, and the sun would never do a straight line going above your head. The sun would always be turning at the horizon at the North Pole. So the sun never sets in Sweden and Scandinavia during the summer. It keeps going around the horizon, and it's never above the head or below the horizon. It's at the horizon. Sometimes it's twilight, where the sun is below the horizon. But even though it's below the horizon, you still get light because it's not a ball. Well, peep this out, guys. This is very interesting here. Look what happens when we go past the equator and we go to the South Pole. Boom. The South Pole is near the horizon. It's never above your zenith unless you go to the South Wall, which we're not allowed to go there. So no one ever takes pictures of the South Pole directly above your head except for the Army, and it's just a reflection. This dome is reflective, and as that turns this way, like direction.
Yeah.
Okay, so I maybe also had a hard time following it. So can you explain what we just watched?
Yeah, that's heavy stuff. So I think I think he's explaining our vision and how we see the sun, and like how the sun would be on a a circular flat Earth model.
Okay.
Like, so what the sun would look like in retrospect to your personal dome of vision.
Okay, so what it sounded like to me was he was trying to explain how what we see in terms of the orbit of the sun and what it does corresponds with a flat Earth model.
Yes.
That was a little bit different than what I thought initially about how certain celestial bodies would be blocked or something like that. But it seems to me, though, like the rotation of the Earth would produce the same effect, or I guess I'm having a hard time understanding why this model better represents what we see from the sun than the round Earth model.
Well, the round Earth model represents it just fine. That doesn't make it true.
So it's not necessarily trying to disprove the round Earth model. It's just showing that a flat Earth model is still plausible.
Yes, it's just explaining the flat Earthers' viewpoint on how it works.
Okay, I understand. All right, great. Got it.
So it may not be a good intro piece to start out with, but like I said, we're doom scrolling, so
yeah. Well, can you like, just for the dummies in the room, kind of give a teaser or an introductory kind of statement as to why you believe in the flat Earth, and what was the piece of evidence that convinced you personally that this was the truth?
The Bible.
Okay.
So I got into Enoch, and at this time in my life, I thought the Bible was infallible and everything, and it was true. And then I found out we had 100 books in the Ethiopian Bible, and it was the oldest Bible. So I was like, why did they uncanonize Enoch? And so I dove into Enoch head first. I had to take breaks, man, because it got heavy.
Mm-hmm.
So
yeah,
so it talks about the angels being buried under the Euphrates and all that.
Yeah.
So Enoch, I mean, it explains the flat Earth and how the sun and the moon go through portals and all this crazy stuff. So I mean that's what got me initially interested.
Okay.
Or got me initially believing it. And then, I just kind of dove headfirst into like Rob Skiba and guys like that.
Skiba, okay.
Have you heard of him?
No, I wanna write his name down. What's his name? Rob Skiba?
Yeah, he was a preacher. And he fell into all this flat Earth stuff, and he got popular right during COVID.
Okay.
And they slapped what were those things they were putting on people that were killing them?
I'm sorry, say that again?
During COVID, they were putting those things on people's faces.
Ventilators. Yeah, they were killing people with ventilators.
Yeah, they put him on one of those and whacked him.
That's awful. So Rob Skiba. Okay.
Yes, sir. He's great.
Yeah. Well, I'll just while you're looking for something else to kind of demonstrate the point, I'll tell you kind of my first impression of the flat Earth thing. It was Owen Benjamin, and he annoyed me with this. He basically was talking about why satellites are pointed at a 45-degree angle up into the air as opposed to straight up. And he insisted that the satellites, if the Earth were actually round, would be pointed straight up, which I thought was absolute nonsense, because a satellite shoots a wave, and the satellite from space shoots a wave down to the Earth, and a dish shoots a straight line. And so obviously you're going to put that dish at a 45 because it's going to be able to detect that wave longer. And so that's why it goes, that's why it curves, basically, because that's why the satellite dish is at a 45-degree angle, because you want to be able to detect the wave longer. That's also why your satellite dish strength gets stronger and weaker as time goes on. So I don't know any other arguments for flat Earth, but the dish thing really got on my nerves. I was like, I don't know about flat Earth, but I know that's wrong. So that was my introduction to this. So there's no reason for the dish to be shooting straight up if the Earth is round. That's nonsense. But anyway, so that's kind of my introduction to this whole thing. Now, I've never heard the orbiting stuff, so I'm curious to see what else is out there.
Okay. That was kind of snarky. I'm not going to click on that.
And I'm just kind of open to whatever right now.
I hope the Earth is flat, but I'm spiteful. Like, I mainly want it because I want the scientists to be wrong. I just want them to be wrong. That's a horribly childish way to look at it, but I'm childish. Sue me.
I don't think it's childish at all. I mean, you know who they are, right?
Yeah, well, after COVID, COVID changed a lot.
Have you heard of Operation Paperclip?
Oh yeah, yeah. They were.
Yeah, I mean, the scientists are all just Nazis.
Yeah,
So
a lot of them. Yeah, yeah.
there's a natural instinct to want them to be wrong.
Well, I mean, I just, I grew up with the whole creation evolution debate, and I'm not so much a creationist anymore. I tend to agree more with the ID guys to an extent, but I do remember how bullied creationists were, and I remember how angry that made me, and that's really put me off against scientists.
Kind of like Kent Hovind.
Yeah, Kent Hovind was horribly bullied, and then the IRS put him in jail, and you'll never convince me that that was on the up and up. You know what I mean?
Yeah.
Yeah.
Like that was one of the worst things I ever saw, personally, was just the way Kent Hovind was treated.
Yeah.
And I mean, I've never trusted the scientists since then. So.
Well, you mean you don't trust Neil deGrasse, I think is his name?
Oh, did you unshare your screen, Cody?
Yes, I did.
Okay, well, we're going back to the other scene. Okay, so sorry. Just let us know when you find something. We'll share it again.
Yeah, I'm pulling something up.
Okay.
I was trying to pull up a
pull it up.
representation of 8 inches per mile squared. So you guys can chew on that for a minute.
Okay.
8 inches.
Well, just let us know when you're ready, and we'll pull it up. But no, it's so infuriating. Like, I never necessarily, I agreed with Hovind on some things and not others. I think the radiometric dating stuff is nonsense. I don't know if I agree with anything else he says. Well, some of it not. But the point is, when somebody is bullied like that, when the IRS is sicked on somebody like that, I mean, you want to stand up for them, and you want to advocate for their ideas, even if you don't necessarily agree with them. Because it's like, you know what? Forget you guys.
Yeah.
I hate bullies, and the scientific establishment, they've just been bullies for forever. And so I want them to eat crow. That's really what it amounts to.
Yeah. Well, I mean, okay, I went ahead and shared it.
Okay.
You walk outside, man. You don't feel like you're spinning unless you're drunk.
Well, I think that might have something to do with centrifugal force, but you could be right. I don't know.
Yeah. Okay, so can you see this?
Yes. Let me adjust the window a little bit. Make sure we're good and centered. Okay. Let me refresh that. All right. Whenever you're ready.
So this screen grab is the conversation that this is based off of was between a guy named Robotham. I think he's one of the NASA directors. But essentially he's saying he was saying he could see the sun, he could bring it back into view, right? And he was like, why can I bring the sun back into view?
From a telescope?
Right? Yeah, with whatever.
Okay.
A P900 or whatever. So you can bring the sun back into view when it should be over the edge of the earth. Right? So there should be curve in front of you.
Right.
And so this Wallace guy countered Robotham's observation with refraction. So, like you stick a stick in the water and you can see it refract up.
Okay, yeah.
Okay, well, he's saying you can see the sun because the image is bouncing off of the atmosphere or the ionosphere.
Mm-hmm.
Atmospheric refraction.
Okay.
Can distort the apparent position of an object. So he's saying it's a reflection. Okay. It's like an optical illusion that you'd see in the desert, which doesn't make sense because that would refract up, I think, instead of down. No, I don't know.
Okay, so I'm confused. So is this another way to kind of explain Just
seeing too
what
far.
we currently see with the sun, or is this like something that would render the round Earth model impossible?
Well, whenever a boat goes over the edge of the horizon, the claim is that you see it for 3 miles and it drops off the edge of the Earth or over the curve of the Earth, and that's why you can't see it anymore.
Right.
But you can just zoom in and bring it back into view.
Okay. Yes.
So why? Well, the scientific establishment says it's because the image is bouncing off of the atmosphere.
Okay. Okay. So this is to explain the scientists' explanation for why we can see ships further than 3 miles out.
Yeah.
Okay. All right.
And it's ridiculous.
Gotcha. Yeah. No, I wasn't going to say that, but I was like, well, that sounds like nonsense, whatever this is. So,
yeah.
The refraction, there'd be signs of distortion if that were the case. Like there'd be a waviness to the image or what have you. It'd be unsettled.
Which there is sometimes, but yeah, I mean, you get that with anything.
Yeah. With
any kind of photography. I mean, like,
well,
think of a good example.
Heat waves would do it.
Right.
It's a question of severity. Yeah.
So it's like if you get to a distance of 100 miles and you're looking through a camera or whatever, I mean, those waves are going to be distorted.
Yeah. Okay.
So the image is going to be distorted just because of you're looking through a medium. Like all air has water in it.
Mm-hmm.
So like the water in the air is acting like a lens and distorting it. That's all.
No, I can see that. Yeah. Okay.
So the 8 inches per mile squared. Okay, I'm going to go ahead and stop sharing.
Okay, let me bring back our regular scene.
Pull up this other.
What do you think of that, Trevor?
I think that's pretty cool.
I ain't bright, so I'm like, I think I understand that.
Well, I have seen kind of a video to go along with that where people, like, they're just out and about and they're looking over the ocean and they see these full-on cities.
Yeah.
out over the ocean. It's like, how does that happen?
On Twitter, I shared a video of a camera just going on and on and on and on and on and into zoom.
Oh, yeah.
Definitely. Yeah.
I've seen one of those.
Yeah.
So, and they just keep going.
Yeah. Which is interesting. I don't know how I feel about it, but it's interesting.
Okay. Sorry, boys.
No, you're good. I do think I wish we knew, like, people who debated this stuff. Because I would like to listen to a debate. Because I'm sure there's counter arguments to these anomalies, and I'm sure there's a back and forth.
Yeah.
There's one on right now.
You know
oh,
who
yeah?
Neil deGrasse is?
Oh, that turkey, yes.
He's awful.
He's the worst. He's the twit that downgraded Pluto.
Yeah. That dude literally just makes stuff up.
Yeah, I can't. That guy.
Okay, hey, I've got a thought experiment for you here.
Okay.
Okay, so if a plane, an airplane, commercial airplane, is flying at 30,000 feet.
Uh-huh.
Sorry, my eyes are tired. I can't read any of this, so I'm going to have to go off the cuff. If an airplane's flying at 30,000 feet, if it's not nosing down, just like a spaceship, so they go straight up, right, and then they actually curve and dip off. But
yeah.
So an airplane, if it's flying flat, and you've got a curve over here, right?
Yeah.
So it's flying. Isn't it going to have to nose down, like all the time?
Well, I would think so, but I don't think you would notice it or feel it necessarily.
But you would have to.
Well, yeah, but gravity's pulling everything towards a central point. So from our perspective, it would
hard, man?
Pretty dang hard, from what I understand. I don't know.
You're fighting that gravity pretty hard.
Yeah, I mean, you would be fighting. That's why well, from what I understand, that's the case. That's why it takes so much fuel to get off the ground. Is you do have to fight. You have to get that centrifugal force to override gravity. And then even when you've got that force enough, not centrifugal force, the thrust force to override gravity. And then even when you've got enough force, it's still going to pull you down to an extent. You're going to be able to minimize that with wing, the wings catching the air and stuff, but you're still ultimately going to be fighting that gravity the whole time. And that would create the illusion that you're flying flat, even if you're not. I'm making that up off the top of my head, and it's a thought
it checks
experiment.
out. I think that's right.
Yeah. So I think we need to take a step back, though. So when we talk about the flat Earth model, are we talking about the Earth being kind of like curved, like a dome, but essentially shaped like a coin, or is it like completely flat? Like how flat are we talking? Like what? I'm starting from zero, so I need to know like what is the exact theory? You know what I mean? Like if I was to sit there and explain what the regular theory is, I'd be like, okay, so the Earth is a spinning ball. And it's not so much that everything, the stars and the moon and everything are spinning around us. We're actually rotating, and we're seeing everything as we rotate. So we're rotating on an axis, and as we spin, we see the different constellations, the sun and the moon and everything else. So so if it's not a ball, is it a coin? Is it like half a soccer ball? Like what exactly is the theory?
I mean, I don't make any claims to know what we're on. I know we're not on a ball.
Okay.
I mean, I used to think I knew, but like I found I'm in the same boat as everybody else if I sit there and say I know where I am,
Yeah. Well,
I can't make that claim. I've barely been out of my state.
Are there multiple theories? Is there just one? Like, do different people have different ideas?
It makes sense that there's a circle. And the Bible says the circle of the earth. So the circle and the dome and the firmament, that all makes sense to me. But I know the sun does an analemma, which is a figure 8. So I don't know how that works. So based on that sun thing, I don't know what shape it is.
Okay.
It doesn't check out.
So maybe a good place to start with this then would be to basically demonstrate why the round Earth is impossible, and that there has to be another explanation. So maybe we could start there, because that's what Hovind would always do with his presentations about creationism. He would always start with why evolution is stupid and untenable and impossible, and then he would end his lecture series on his theory about what happened, and he had the ice dome theory and different things like that to explain the anomalies that made evolution impossible. So he would pull up a bunch of facts that eliminated one possibility, then he would try to explain those facts with his own hypothesis. Does that make sense?
Yeah, that's not really my style, but yeah.
Okay. Well, it worked for me because I was stupid and didn't know anything. So maybe if we could talk about next time, because we're at the 30-minute mark, if we could talk about what makes the round Earth impossible. So if we could disillusion people of their pre-existing notion and then build up from there, maybe that would be at least a better way for people to kind of understand what the issue is. Does that make sense?
Yeah.
Okay. All right, so we will do that next time. We do need to wrap this episode up. And
I can definitely do it right now.
Well, we're on that 30-minute block, so we're gonna pick it up next time at the beginning of the next podcast. So,
all right,
guys, thank you very much for watching, and we'll see you in the next video.
Thank you.
We hope you enjoyed this episode of Faith, Fiction, and Folklore. If you did, we would love it if you would subscribe to us on YouTube or follow us on Rumble. We can also be found on X, Instagram, and Facebook. And we are available on Spotify, Apple Podcasts, Amazon Music, and iHeartRadio. Thank you again very much for listening, and we'll see you next time.